Geometry Trig Honors 8.1. Right triangle trig and applications. So this is going to feel a bit backwards considering what we've already done, and then there's just a bunch of little things tossed in. Not my favorite way to teach, but sometimes it's what we have to do. So we get a triangle going here, and we label it, and very often we label it ABC with C being the right angle. Slap a theta in here at B, and the adjacent side's 3, the hypotenuse is 5. From A squared plus B squared equals C squared, we know that this side is 4. So now we can do all 6 trig functions. And I like to do them left to right. Sine of theta, or B, 4 over 5, where cosecant of theta is 5 over 4. So I like doing them this way. It's just so easy to go, oh, cosine of theta is 3 over 5. Therefore, secant of theta is 5 over 3. If you don't know your secant, cosecant, sine, cosine, tangent, this is not the video for you. We've already done all that. I'm not going to go over it again. Go watch an older video. All right? So there they are, the 6 trig functions. Now, what if we just had an angle here? Well, then we'd just get decimals. We'd get 0.8, 0.6, and so on and so on. And maybe they'd go 2 or 3 places. It's not a big deal. It's up to you. It's not critical. So now we can start writing some application problems. We have this long piece of aluminum. It's 12 inches total, and they break it into 4s. Then they bend it. And again with the 4 inches. And they say, hey, we want to max out how much water this thing can carry. So call that theta. What would theta be? You know, we've got a machine in the shop that's going to bend it. What would theta be to max out the area? Just to be clear, we're talking about that area there. Well, that's a trapezoid. Area of a trapezoid, 1/2 height times base 1 plus base 2. So, where else can we write theta? Put it up here. And I think it might come in handy to say sine of theta, we'll call this x, and cosine of theta. Sine of theta is opposite over hypotenuse, h over 4. So that h equals 4 sine of theta. Cosine of theta equals x over 4. So x equals 4 cosine of theta. And now we can look at this and say, well, this is 4. This is 4 cosine of theta. This is also 4 cosine of theta. And the height is 4 sine of theta. So this is actually very much a calculus problem, because you would actually blast this out. 1/2 4 sine of theta. 4 plus 4 cosine of theta times 2. It's 2 of them. And you could simplify a little bit, but long story short, you're going to get 2 sine of theta times 4 plus 8 cosine of theta. You graph this in your calculator, and I have no idea what it'll do, but it gives you some shape. And you say, hey, where's that max? Theta versus the area. And that is the angle you want to go with. And having done this before, you're going to get 60 degrees, aka pi over 3. Put it on your calculator, see if you agree. Back to that triangle up above. I've already forgotten what it looks like. 3, 4, 5 on the bottom. And I labeled it. What do you notice about sine of A and cosine of B? I'll get rid of theta this time. They're equal. Sine of A is 3 over 5. Cosine of B is 3 over 5. These are called cofunctions when that happens. Since a and b add up to 90, we can write it like this. Sine of a equals cosine of 90 minus a. And that's a cofunction. Tangent and cotangent are cofunctions. Tangent of a equals cotangent 90 minus a. And secant and cosecant are cofunctions. Notice I just randomly picked the first one to go with, sine, tangent, secant. You could write it backwards. Cosine of a equals sine of 90 minus a. This pops up a little bit. I don't even know if I use it much here, but that's about it. We talk about solving triangles, and this one's a little bit nebulous, and I apologize for that. Usually want to say what the right angle is, but in this one it's not as important. We'll go with A down here. Does not matter where you put it. C. Want to solve the triangle means find all the sides. Little b is across from big B, so that's 2, little a, and little c. First things first, measure of angle B, 90 minus 40 degrees, just like that whole cofunction thing we just went through, is 50 degrees. And to find A, we would try tangent. Literally try. See if it works. Tangent of A, of 40, is little a over 2. A equals 2 times tangent of 40. I will no longer write these out. I fully, completely, and totally expect you guys to be able to handle something like that. So now my calculator, I go 2 tangent of 40. Make sure your calculator's in degrees. I get 1.7, and I like going with 1 decimal places. And now I could do a squared, b squared, c squared, but I like to use my original information. So I'm going to do cosine of 40 equals 2 over a, c. And a lot of people get lost on this. Well, I don't see how to, if it really comes down to it, go ahead and cross multiply, but I can just replace things because multiplication is a commutative operation. So c equals 2 over cosine of 40. So that's what it means to solve a triangle. You have to have all 6 sides, all 3 sides, all 3 angles, all 6 measurements. Try it again. This one's not clear. We'll make some assumptions. I said sorry for the nebulousness. Let's make this 3, so this is big A. Make this 2, this is big B, C, and little c. Now, since these are original numbers, I'll just go and get C with the Pythagorean theorem. Since we're doing decimals, I'll write them both. If I want to be precise, I could leave it as a radical. Tangent of A equals 3 over 2. A equals, and this is probably the hardest piece of this unit that people always forget to do, is the arctangent. Again, we've done this before, so you should remember how. And that's 56.3 degrees. A lot of people are going to do tangent of B equals 2 over 3. B equals second tangent, and I'll write it out. I was going to say I'm just going to blast it out. But before I hit my calculator, I'm willing to bet it's going to be 33.7 degrees. And if you're smart, you'll say, oh yeah, because this and this have to add up to 90, and that would have been a bit of an easier way to do it. Basic arithmetic. So, how about an application problem? You've got your lodge down here. Make sure you got smoke coming out of the chimney. It looks nice and warm. And they look up and see a really nice scenic overlook out here. You're there and chilling out. And it's up here at 11,100 feet. The lodge is at 8,000 feet. So, a little math, 3,100 feet. But they say the trail is 2.7 miles long. Better be a really straight trail or else this is not going to work. So 3100 divided by 5280 is 0.5871 miles. At this point, you might say, wait a minute, I thought you were going to one decimal place. Well, my final answer is one decimal place. I don't want to lose too much accuracy, so during the process, I'll leave a bunch of decimal places. Better yet, I'll use the value that's in the calculator. So we want the angle of inclination. I believe that's going to be a sine problem. That could be wrong, so let's go find out. Sine of theta is opposite, 0.5871 over 2.7. Cool. Theta equals, and I'm blasting it out with the original data on my calculator, 12.6 degrees. So that's the angle of inclination over here. By the way, what's the angle of depression if you're standing up here? Should recognize that it's theta. It's the same. Why? Because alternate interior angles. Hey, look at that. You just took geometry, so it all ties together nicely. That's a math teacher trick to ask for the angle of depression. It's the same thing as the angle of elevation. Always put it on the bottom. And one last thing. This has all been pretty quick. What's bearing mean? So this is bearing north 30 east. Hopefully you know, never eat soggy waffles or never eat sour watermelon. It's a compass. So bearing of this being north, 30 degrees east would be this. Meaning go north and then go to the east 30 degrees. You're going to need this for problems we're going to do later. It's really not that big a deal. South 50 degrees west would be something like this. South 50 degrees. So this is south 50 degrees west. That's about it. As always, go do some problems and make sense of the world, and happy mathing.